Okay, before we end the lectures on sequence and series, there are two things that are worth talking about. The first is the summation sign, which is also known as sigma. This is technically capital sigma. So what happens is it usually goes like maybe 4R, and then R equal to some number in the bottom and some number on top. Alright, it's called the summation sign because you're supposed to add stuff up. Alright, what do you add? You add this. You add the thing inside the summation sign. Alright, so the first term that you're adding is 4R, except R is not R. R start with the number in the bottom. Alright, so in this case start with 2, and then you add, so plus 4 times R again, but this time R takes the next value. Alright, so after 2 is 3. The next one, so it's 4 times the next value of R. Alright, then the question is, when do you stop? Alright, you stop when R reaches the top value. So in this example, it is 5, so we stop when R goes to 5. So what usually happens is when you see a summation sign, you can work out like the first 3 values. So in this case, 8, 12, and 16. Alright, then technically the last value doesn't really matter. Let's pretend the last value is like pretty big, so we can't actually find out what that is. But the key is with just the first 3, you can kind of see what kind of sequence it is, right? Or what kind of series it is, because we're adding. Alright, so this one you see you keep adding by 4 to get the next number. So you decide this is an arithmetic sequence. Alright, then you simply go to your formula booklets. Alright, and you go to like, this is arithmetic, so you do the arithmetic sum formula. Alright, and n over 2, so you see how many terms are there. From 2 to 5, so you have what? 2, 3, 4, 5, so there are 4 terms. So 4 over 2, 2 times u1. Well, the first term is the first number there. And it's again 4, the common difference also 4. Right, you just compute this, then you found the value of this summation sign. Now, it is important for you to list out the first 3 numbers to check what type of sequence it is. Alright, sometimes it's pretty obvious. This one is arithmetic. Let me give you an example where it would be geometric. It will be something like from 1, alright, then like 4 half to the power of R, I don't know, plus 1, and then to like 10. Alright, this is, if you can see it, would be an example of geometric, but it's fine if you cannot. You can just list out the first 3 terms to see what type of sequence it is. Alright, so if R is 1, so you put 1 in here. So that would be 4 times half to the power of 2 plus the next value of R. So R is 2, 2 plus 1 is 3. And then 1 more, so 4, so on and so forth. When do we stop? We stop when R is 10. So 10 plus 1 is 11. Alright, 10 plus 1 is 11. Okay, so what's this? Half to the power of 2. So you square both the 1 and the 2, so it's 1 over 4. Half to the power of 3, 1 over 8. And then half to the power of 4. 1 to the power of 4 is still 1, 2 to the power of 4 is 16. Alright, keep going. The last number, we don't really care. Okay, 4 times 1 over 4, that's 1. 4 times 1 over 8, so it's like 4 times 1 is 4, 1 times 8 is 8, 4 over 8, so that's like half, plus 4 over 16, so let's cancel out, so it's 1 over 4. Okay, then it should be clear now. This is geometric, with first term being 1, common ratio being half. Then you can use the geometric formula. So u1 is 1 times r to the power of n. You know both of them are the same, so you can use either one to the power of n. So how many terms are there? We go from r being 1 to r being 10. So there are 10 terms. So n is 10 minus 1 over half minus 1. Okay. It is also possible that instead of having an actual number on top, they just write an infinity side. Then this would simply be a sum to infinity. All right, so there's no last term technically, it's just plus dot dot dot, which means the sum goes on forever. Then in that case, you use the sum to infinity formula, which is of course given. And by the way, I have the old version here. There was a typo. Sum to infinity is actually u1 over 1 minus r. So be careful if you have downloaded that version. A lot of websites have not updated, but IB have. IB have updated the former booklet scenes. Right, first term is 1. Then this is simply 2. Another formula that's worth talking about is the compound interest formula. All right, which is again given in the former booklet. So it's here. All right, that's actually a formula for compound interest. It becomes a kind of a popular topic under the new syllabus. So let's talk about what the symbols means. All right, present value, PV, present value, is how much you put into the bank. So it's like a deposit. Future value would be the amount of money you get if you're doing compound interest after n years. So this n is the number of years. And when you put money into the bank, there's an interest rate, right? The annual interest rate, so the interest rate you get per year. That will be this R. All right, usually it's like if it's 4%, then you would put this R to be 4. Because the way they make this formula is like this 100 is the percent. All right, so if it's 4%, you just put R to be 4, so it would have 4 over 100 R. Well, then the next problem is, what is this K? K stands for the number of times they calculate the compound interest per year. All right, how many times they do compound interest per year? So what could happen is the question would say, all right, this bank would give you compound interest like half yearly. Well, that would mean K is 2 because they give you compound interest every half a year. So in a year you get it twice. They can say like quarterly. That means K is 4. It could also be monthly. All right, then K will be 12. And then one interesting thing is, turns out the more frequent they calculate compound interest for you, the more money you will get at the end. Not by a lot, just a tiny bit, but technically a little bit more. And lastly, let me show you a question in the specimen paper to have a quick demonstration of how to use this formula. That year was this is a specimen of SL. It's always pretty straightforward if they are testing you on compound interest. So there is some interest rate of 5.5%, compound quarterly, and she start by an investment of P dollars. All right, so that would mean the PV, the present value is P. Then 1 plus R over 100K, right? R is the interest rate, so 5.5 over 100K. K is quarterly, so 4. And don't remember you have also a K here, so that's the same K, so it's 4. N is how many years have passed. The interesting thing is you can view this, you can view the money you have in the bank at the end of each year, so that means after you get the interest of that year, you can view the money you have as a geometric sequence. Okay, because what happened is after the first year, how much you will get? Well, you will get basically this, but with n being 1. So you get this. But after another year, after the end of the second year, you would get like this amount. All right, where 4 times 2 is 8. All right, and the question told you you can view this as a geometric sequence. That means you're multiplying by the same number every year to get the amount that you'll get in the next year. The question is, what's the common ratio? Well, as we have seen, you can find the common ratio by taking the second term and divide that by the first term. All right, so R would just be this over the amount you have in the first year. Then you can see the P cancel out. And then you have the same thing raised to the power of 8 over the same thing raised to the power of 4. By law of indices, we have something like 8 to the power of 8 over 8 to the power of 4. So we know we just minus the power. So that's 8 to the power of 4, so it is this. All right, so this is the common ratio. If you press the calculator, you will get a value of 1.056. So this will be a quick demonstration of the relation between compound interest and sequence. That's why usually, including the syllabus, put this inside the topic of sequences. But to be honest, all you do is using the formula that the formula booklet provides to you.